Welcome to this session on Relational Database Management System. My name is Ashish Jain. I am an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. We will be continuing with our module on data models. In the previous modules, we have seen hierarchical data model, network data model. Today, we will see relational data model. This is the most commonly used and a very widespread data model. Here in this session, we will be covering introduction to relational data model, terminology of relational model, the structure of relational data model. We will see what is a relational schema and what is an instance, and also some constraints on relational models. So let's begin today's session. As the name suggests, relational model, here we represent the data in terms of relations. That is, in this model, database is represented as a collection of relations, wherein each relation is represented by a two-dimensional table. So if you represent data in a tabular manner, such type of data model is called relational data model. This model was proposed by E.F. Codd, and it is the most commonly used data models due to its simplicity of use. After the designing of the conceptual model by using the ER diagrams, we need to convert this conceptual model into logical model, that is the relational model. Here we use relational database management system concepts and we will make relational model. Then we can implement this logic to make tables using different relational database management system packages such as Oracle, MySQL, MySQL Server, etc. Here, relational model represents how data is stored in relational databases. However, the physical storage is separate from the logical representation. This is the concept of data independence. That is, the physical representation of data is different from its logical representation. The relational model provides the basis for first the research on the theory of data, relationship and the constraints, different database design methodologies, and a very standard database access language that we call SQL, which stands for Structured Query Language. Relational models describe the world as a collection of interrelated relations or table, and any database using relational model is known as Relational Database Management System, that is RDBMS. Let us see some advantages of relational model. First of all, it offers us the ease of use because it is very easy to use and understand. It allows flexibility, then it allows accuracy. In ease of use, by the use of simple tabular representation of data, we can easily understand the things that is represented over there using the relational model. Also, we can easily query the database whenever required. By allowing flexibility, it allows users to manipulate the data very easily on various tables. Accuracy, the relational databases allow algebraic operations, relational algebraic operations to be performed for the manipulation of data. These are mathematical operations and also they ensure accuracy in the answer. The other advantages of this model include it offers structural independence. Tabular view improves the conceptual simplicity. The query capabilities is based on structured query language. It isolates the end user from the physical level details. It improves implementation of various business rules, and also it offers management simplicity. But it also has some limitations, which includes that it requires a substantial hardware and system software overheads. The conceptual simplicity gives untrained people tools to use a good system poorly. What does it mean? It means that if a user is not properly knowledgeable, then it is very hard for that user to understand what is represented. So, we have to have some kind of knowledge to understand the data represented in tables. Let us see some terms that are frequently used in relational model. First of all, relation. A relation is a saved form of tables. That is, whatever we store in table, we call that table as a relation. A table has rows and columns where the rows represents different records and the columns represents different attributes by which we can refer to different values that are stored in that. Then we have tuple. Within a table, each row represents a group of related data values. It's called a row. and this row is also known as record or tuple. So if you're talking about a table student, it will contain different columns pertaining to different values related to students, such as student ID, student name, class, section, etc. All these are just values, but we have to have some values that represent those quantities. So if we have a data, say S101, which is a student ID, name is say XYZ, you have certain class and other values, one full row of data is known as a record or a tuple. A table containing n attributes in a record is called n tuple, where attributes are the number of properties by which we represent the data of the different entities. What is an attribute? An attribute is the pieces of information or facts which is represented in an organized way in columns and tables. So what are columns we have, we call a column as an attribute. For example, in a student table we have 5 columns, so we can say that we have 5 attributes. An attribute defines record, and a record contains set of attributes. Then we have the term called domain. Domain is a set of permissible or allowed values that an attribute can have. For example, if I have a column called gender, I can have values such as male, female, or other values if you want, right? Apart from these allowed values, we cannot enter any other thing so that our data remains in a very consistent state. This is called domain. The values to attributes cannot be assigned outside their domain. And also, a domain can be represented as it is a set of acceptable values that a column is allowed to contain. It is based on various properties and data type of the column. So based upon the type of data we need to store in a column, we have different types of domains for that particular column. Then we have the term record. Record allows us to break down the data into its constituent bits for storage. It contains fields that are related. So another term for this record is tuple. So we say that a relation means table, attribute means a column or a field of a table, and tuple means row. Let us understand with this diagram. Here we have a table, and this table is named as, say, suppose student. So in this student table we have 5 columns: student ID, student name, address, birth date, and the gender. Here we have 5 columns, so we say that the degree of the table is 5. What is degree? Degree of a table is actually the number of columns in that table. So we have 5 columns here, the degree of this table is 5. Also, the number of records, we have stored 4 records here, that means we have data of 4 different students here. So this number of record is called cardinality. So in a table we have 2 important factors. First is degree, second is cardinality. Degree means the number of columns and cardinality means the number of rows. And also in every table we have one such column or attribute value which is used to clearly distinguish between records of the same type and the same value. Such a column is called a primary key, right? So we have the student ID whose value is not repeated for any other student, right? This is called a primary key field. So we have columns or field or attribute. We have domain. Domain is set of allowed values. So in the column of gender, we can have only 2 values, either female or male. That's why the domain of this is female or male, right? Now we come to relational schema. Schema means design. A relational schema specifies a relation's name, its attributes, and domain of each attribute. How it is designed. If we say that capital R is the name of a relation which contains attributes such as A1, A2 and so on, we can represent R as R of A1, A2 up till AN. This is called the relational schema, the overall design. Here A1, A2 are the names of the columns and R is the name of the table. We can also say that it is a subset of Cartesian product of a list of domains which is characterized by a name. Cartesian product means the cross product. Each attribute in a relational schema takes a value from some specific domain which is represented as domain of AI, where I can be any column. For example, we have a relation, the name is person. Here we have ID of a person, name of a person, age and address. ID is integer type, name is a string type, age is again integer, address is string. So this is called the design or the schema. The total number of attributes in a relation is called degree of relation, and the number of records are cardinality. Now we come to relational instance. The instance or state is a collection of tuples for a given relational schema at a specific point of time. If we talk about only the structure, we call it as relational schema. If we talk about the values that satisfy the requirements of that particular structure, it is called an instance. That means one filled record or a tuple is called an instance. Here we can say that instance is a set of n tuples such that R, T1, T2, these are the different tuples we have, where each n tuple is an ordered list of n values. So whatever is the number of columns, we have the values in each column. A relational schema is also called intension, and the relational instance is called the extension. Now we come to different constraints in a relation. Constraints are basically bounding conditions that allow us to imply some kind of rules in our database so that we don't allow the unrequired values in our table. These constraints are checked before performing any of the operations in the database. If there is a violation in any of the constraints, the operation will fail. We call this as anomaly. Anomaly means a situation which is not desirable. So in database we can have anomaly at three different places. First, at the time of insertion of data, second at the time of updation of data, and the third at the time of deletion. So we have insertion anomaly, updation anomaly, and deletion anomalies. Regarding the types of constraints, we can divide it into three categories. We have domain constraints, we have key constraints, and we have the integrity constraints. Let us discuss them one by one. First is the domain constraint. A domain constraint specifies that each attribute in a relation must contain an atomic value only from the corresponding domain. That means whatever is the set of allowed values, you can only have one value from that domain in a particular column position. It specifies that the condition that we want to put on each instance of the relation. Also, the values that appear in each column must be drawn from a domain associated with that column. If you have a column, say age, that means what all values are allowed in this column should be of integer type. That means it should be numerical value. This is known as attribute level constraint because it is applicable to the whole column. For example, if we have a constraint called age, that is age more than 0, and if we try to enter any negative value of that age, it is a violation of the constraint. It won't allow. Second type of constraint is key constraint. This constraint states that the key attribute value in each tuple must be unique. That means whatever value we are using to distinguish between different elements, that value should be unique. If you have allotted a particular ID, say suppose roll number or an enrollment number to a student, it cannot be repeated for another student. This is the key constraint. Every relation in database should have at least one set of attributes which defines a tuple uniquely, and we call it as a key. Generally, we use a primary key in a table. This primary key, what it does, it implies two conditions at the same time. The first condition or constraint is that our value should be unique and it should not be null. That means whatever is the value of the primary key for any particular variable, it is not repeatable. Second, we cannot leave it blank. We have to enter one value of primary key that is not repeatable. For example, roll number in a student table is a key value, so no two students can have the same roll number. Then the third type of constraint we have is integrity constraints. Here this constraint helps to ensure that the integrity of data values are represented in a relation. So what all you have decided to maintain the consistency of the data, that should be represented in a relation properly. There are two types of integrity constraints. First, we have the entity integrity constraint. Second, we have the referential integrity constraints. Let us see them one by one. The entity integrity constraint states that no primary key value can be null. That means you cannot leave the primary key value as null. This is because this primary key is used to identify individual tuples. If this value is null, we are not able to clearly distinguish between records. Second, referential integrity constraints. It happens in a table that we connect tables based upon some kind of relationship, and the value of one table can refer to the value of the other, right? So in a referential integrity constraint, it states that the tuple in one relation that refers to another relation must refer to an existing tuple in that relation using the concept of foreign or reference key. Let us now understand this. Suppose I have two tables, one is say student, second is a course table. So I have a listing of all the courses that are being offered, and in a student table there is a column of course in which it is to be mentioned that which course a student opts in. Now if a student is entering a course number which is not there in the related table of the course, then this is a violation of referential integrity. That is, this table is not able to refer to the value of the course. That means this course doesn't exist. So such cases are called referential integrity constraints. So we have two constraints here. First is entity integrity and second is referential integrity. In this module, let us see what we have covered. We have introduced the concept of relational data model. We have seen various terminologies that are related to relational model. We have seen what is the structure of relational model. We have seen the two properties of degree and cardinality. We have seen what is a relational schema and a relational instance, and also various constraints on relational model. I hope this session is beneficial for you. Until then, happy learning. Thank you.